I'm Julie Choi again, and I'm joined by the amazing Marcy Vu. She leads the venture capital firm practice at Greycroft, and Ari Morkos, CEO of Datology AI. And today we're going to be talking about the future of AI through the lens of data, infra, and venture. And so before we get started, I'd really love for Marcy and Ari to both just kind of say some words and introduce yourself to this fabulous crowd. Let's start with Marcy.
Okay. Hi, everyone. Thanks for having us. My name is Marcy Vu. I'm a partner at Greycroft. We are a multi-stage firm, so we do technology investing from pre-seed all the way up to pre-IPO. And obviously, if you're a technology investor, quite focused on AI over the last several years, and we do invest across consumer and enterprise, infra and applications, and full stack. But I would say that what I really focus on is partnering with founders who are really ambitious and bold in creating new markets.
Amazing. Okay, thank you, Marcy. Ari?
My name is Ari Morkos. I'm the CEO and co-founder of Datology AI. Thank you very much for having me on the panel. A little bit about me, my background. I was an ML researcher for about a decade. I spent several years at DeepMind, spent 5 years at FAIR, Meta's AI research arm before Meta Superintelligence. And my work at Meta in particular really focused on this question of data, and in particular, what is the right data to show to models? One of my favorite catchphrases is models are what they eat. If you show them great data, they're going to be great. If you show them bad data, they're going to be bad. But choosing that data is a very, very complicated process and is a frontier research problem. And if you train on uncurated data, you'll still get a model that's okay, but it'll cost orders of magnitude more to train and will be much worse. So what we do at Datology is we help companies that want to train their own models or customize their own models on their own proprietary data do so by enriching every aspect of that data so that you can train models much faster to much better performance, and also train much smaller models to the same or better performance, which can dramatically reduce the cost of deployment. Thank you very much for having me.
Wonderful. Okay, so we're going to start off this panel by taking us back in time about 2 years to the first day I met Marcy. So I had just exited a startup, so we sold Mosaic ML to Databricks, and I was sitting in a similar room at the invitation of JP Morgan talking about that startup experience. It's been 2 years. Can you imagine how fast time has flown? So I'd love to hear your perspective, Marcy, on what has changed in the AI landscape the most over the past 2 years, and what keeps you excited?
There's so much to be excited about. It's just the rate of change in technology and innovation, and the rate at which you can really build and scale is really unprecedented. And so maybe I'll talk about 3 things. One, what we look for in founders, and that bar keeps getting raised because of how fast you need to act. So it's always been a high bar to be an exceptional founder, but when you look at the generational opportunity we have ahead, it's super competitive, and your ability to learn, iterate, incorporate feedback, incorporate changes in technology, it has always been important, but even more so now. And so the challenge for us is, how do you really find those special founders who can do it just exceptionally? The second thing is, we were looking at 2 years ago, there was a lot of focus on, do you need to build your own model? And that has, and Ari is going to go into this into much greater detail, but we were thinking about like big generalist foundation models, and is that where you need to start? And I think 2 years going by, when we look at startups, it's like you can be model agnostic now. You can leverage open source. You can create specialized models. You can leverage distilled models. And so the idea of one generalist model from 2 years ago, we've now shifted to many specialized models, smaller models, depending on what your use case is. So what does that mean from an investing perspective? We've seen an evolution of investing in model companies to infrastructure companies and now to application companies. And certainly you can be full stack and do all of those things. And so when you look at 2 years ago, we had invested in OpenAI, Pika, NVIDIA. We did the recap of Stability AI, Cartesia. When you look at infrastructure, there are companies like Contextual AI, Coactive AI, Together AI. And then when you look at applications, there's companies like Applied Intuition, Open Evidence. And so you can see this kind of evolution in terms of where activity has been and therefore, where we've been more active. I would say the next thesis area that we're very focused on is security as a horizontal. And AI, you kind of need AI to fight AI created threats. And so I think that's a really exciting area where the last several decades in the playbook in security won't be the right playbooks or products for the next 20 or 50 years.
Amazing, amazing. Thank you so much. Ari, now what has changed in the past 2 years? First of all, congratulations on your 2-year anniversary. Can we all give Ari a big
Friday. Was
round
it
of
Friday?
applause?
Friday
They
was the second anniversary.
I mean, happy 2 years, and congratulations to you and Matthew, one of my colleagues from Mosaic. What's changed the most? What keeps you excited?
Yeah, so as Julie was just joking, our 2-year birthday as a company was on Friday. So I've been reflecting on this, like what has changed in the last 2 years. And it's interesting to see a lot of what has changed and a lot of what hasn't changed. So I think one of the big things that has changed is 2 years ago, I think there was this very widely held belief that the closed source models were going to be just so much better than any of the open source models that there was no chance to compete. And I think related to that, there was this commonly held belief that the cost of training models to the frontier was going to get higher and higher and higher with every successive model. For example, you had predictions, that models in 2025 would cost $1 billion or more to train and develop. I think we've very clearly seen that that is not what happened, right? There are now many, many open source models that are very competitive with GPT-5 and with Claude and Gemini, most of which are coming from Chinese companies. I think that is something that would have been very surprising to most people 2 years ago. I think the other big thing we've seen is that the cost to build a really powerful model has absolutely plummeted. So the DeepSeek V3 costs $5.5 million in marginal compute. That doesn't include the cost of R&D. That doesn't include the salaries. That doesn't include all the other training runs they had to do to figure out how to do that training run. But the marginal cost of building that model, if you knew how to do it, was $5 million. And we've now seen the GPT-OSS models. They talked about how much compute they required. The big one required about $4 million in compute. The small one about $500,000 in compute. So these are really different numbers than what people were throwing around 2 years ago. And I think makes the unit economics of training a model very, very different these days. So I think that's one big change. I think one thing that hasn't changed is while we've seen tremendous consumer adoption of these AI products, and I think we've seen some limited enterprise adoption of AI products. Most notably in the enterprise, I think you see things that are doing RAG-based document search, so the sorts of use cases that Glean or Contextual would support. But we still don't see actually very many AI models deployed beyond that in the enterprise, and that's because they haven't reached the reliability thresholds that are required for enterprise models. Not to mention the cost of deployment is often very high. So I think one of the things that really hasn't changed yet is seeing this real penetration throughout the enterprise, and I'm expecting to see a lot more progress on that in the coming years, in large part through smaller specialized models.
Awesome. Thank you so much, Ari. Okay, so we're going to now talk about data. And I know this is a subject that's very near and dear to your heart. Your company is called Datology. And the context here is back when Ari and I first started in ML, so roughly 2015-ish, compute was the bottleneck, often perceived. And now I really think data is the new bottleneck/opportunity. Ari, can you please tell us about Datology, why you created a company 2 years ago around this thesis of data as central to the future of AI?
Yeah, so I think there are two ways to think about this. And let me first kind of talk about this in the regime of you have a ton of data And then I'll talk about kind of in this now new story that people are talking about of, okay, we have a data wall, how do we actually break through that? So for the first thing to notice is that data and compute are in large part very interchangeable in many ways. The compute that you throw into a model is to look at more data. If you therefore make the data higher quality so the model learns faster from a given set of data, you effectively multiply the value of your compute as well. So ultimately, when you think about training a model, typically the way people come into this is they say, I have a certain amount of budget, I have $10 million in compute that I can spend on this model, I'm gonna show it whatever data I can for that, I'm gonna get performance out of that. Well, in between, you have a bunch of data sitting in storage on S3 to, I'm gonna feed it into a model through a data loader. There are hundreds of choices you would make. These choices are around which data do you wanna show to the model? Do you want to show all of it? Do you want to show some subset about it? How do you want to sequence that data? The order might matter. One thing that actually was different 2 years ago is that the idea that the order of data might matter was kind of something that a lot of people didn't believe in. Now every frontier model is trained using a discrete phase curriculum where you kind of show a phase 1 data mix and then a phase 2 data mix and then a phase 3 data mix, so that's changed a lot. So there's all these choices that you would make in between kind of my data sitting in storage. And these have a dramatic orders of magnitude impact on how quickly your model learns, to what performance it will learn, and how big of a model you can train to that performance. And in order to do this, this is really a frontier research problem. There is a lot of work being done on data curation. This is the main thing that differentiates the frontier models. If you go and you look at the Gemini tech report, it'll say they have a 1-paragraph data section where they'll say data quality was the single most important factor. We use a combination of algorithms and heuristics to do it. And that's all they will say because this is the secret sauce. Well, we don't want to live in a world where only 4 companies know how to do this. So our goal and mission at Datology is to make this, to do this research, drive it, and make it so that anybody can have access to state-of-the-art data curation, which can literally reduce the cost of training a model by 10x or more. It can make a dramatically different impact. I really believe we're going to be in a world where every enterprise will be able to train its own models for $1 million, which is really not very much, and be able to access its proprietary data in this really critical and important way. And democratizing ML is a real important part of what we do at Datology and why it's so impactful. So that's kind of a little bit about what we do at Datology and why that's really important and why you can think of higher quality data as effectively a compute multiplier. It makes it so you get 10x more out of your compute because you're looking at much higher quality data. The other aspect is, you hear the story a lot, we've run out of data, we've mined the internet's done. Well, first of all, the internet is a very, very small minority of the total data that exists in the world. The vast majority of data in the world is proprietary and sitting on company servers, and we want to help companies actually unlock the ability to access that data and get value out of it. So that's kind of the number one. There's a lot more data, it's just private. But number two, the data wall really only matters if we're using our existing data sets to maximum utility. And we are very, very, very far from that. So there's a lot more juice we can get out of our existing data sets, both through curating and filtering them. But another really big aspect of this is synthetic data. How can you actually use your existing data to make more data that is going to be really accurate and that can reflect that? So there's lots of ways we can get past this data wall, not just by sourcing new data, but also making better use of the data we already have.
Wonderful. Thank you, Ari. Now, Marcy, I know that you're working with some of the biggest enterprises. Many of your portcos are working with huge companies and proprietary data, right? I'd love to hear some thoughts from you about the role of proprietary and how that's creating kind of a moat for your portcos, and any other thoughts you may have about data.
Yeah, so totally agree with Ari. We're very early days in terms of being able to unlock the data that we have, particularly within the enterprise. And when I shared about some of our investment areas, and I rattled off a bunch of names that all had AI in their name, we do actually spend time investing in businesses that maybe are not AI first or AI native, but we call it AI accelerated. And so they have proprietary data, they have customers, they have distribution. It's just they weren't started in 2023, 2 years ago or later. And maybe just to give an example, I don't know, how many people here know Whatnot? Awesome. So it is the #1 live stream shopping platform in North America and in Western Europe. Julie and I were chatting. She can't get her hands on a Labubu.
See one right there? This one, oh my God. I need to talk to you about
I told
this.
Julie, go on Whatnot.
Labubu.
So we recently led the Series E in this company, fastest marketplace to surpass over 3 billion in GMV. We're growing triple digits. But if you think about the amount of data that they have with respect to sellers, with respect to buyers, our average buyer watches 80 to 90 minutes of Whatnot every day. And so we just have billions and billions of hours of live stream data. And we were chatting that maybe we need to talk afterwards in terms of how can Whatnot leverage datology in order to like unlock that. But that's one area that we're super excited about. And they're just cracking the surface of this. And then the other companies that we invest in help enterprises unlock the value of their data. And so when you talked about democratizing ML, one of our founders, Cody Coleman, who's the founder of Coactive AI, that was his PhD thesis at Stanford, democratizing ML. And so what they're doing is how do you help enterprises leverage like the massive repositories of multimodal data. They specialize in video. And so when you think about like, we talk about data lakes, no, this is like data oceans that we haven't unlocked yet. And then, companies like contextual AI, one of their strengths is how do you do real-time, unstructured data retrieval at the right point in time. And so I think along that kind of data stack, there's a lot of invention and innovation still taking place so that you can actually pull the right data at the right time for whatever your use case is, in addition to how you might be able to do it more efficiently to train your models.
Thank you so much. Now, proprietary data, and this whole topic of data, I'm sure many of you have heard we might be running out. I want to talk a little bit about synthetic data. And Ari, can you please break that down for us? Like, what is this synthetic data phenomenon?
Yeah, so synthetic data is something that we're extremely excited about. It's been something that we've been working on and pioneering at Datology since day one at the company. And I think is a really promising and powerful path to building better models. Synthetic data also, like many things in deep learning, is very easy to do incorrectly and is very easy to actually do in such a way that harms model performance. So I think one thing that some of you might have heard about is this idea of benchmaxing. You get models that are really, really good at benchmarks, but are not really good in real world use cases. In general, those models tend to be trained on too much synthetic data. So like all things, it's a dual-edged sword and you have to use it correctly. But if you can, it can unlock massive capabilities. So when we think about synthetic data, we actually just released a week or two ago kind of a big blog post summarizing our synthetic data generation paradigm called Beyond Web. And there are two kind of high-level ways you can think of synthetic data. Way number one is to create net new data. So you ask a model, hey, produce some data points about biology or whatever, and you ask it to produce this. In this case, all the information is coming from the model itself, and this means that you can only ever teach a model something that the synthetic data generating model already understood. So in this way, you can kind of view this form of synthetic data as model distillation in disguise via that synthetic data. This is what we see most commonly used. However, we are big fans of a different approach, which we call rephrasing or rewriting. So the approach here is instead of asking a model to produce data net new, you instead give the model a high-quality data point. And how you identify what that high-quality data point is really critical. But you identify, hey, here's a really high-quality data point. Modify this data point so that it's in other formats and other different presentation styles that would teach the model this information in many different ways. What's cool about this is that the synthetic data model now does not need to actually understand deeply the data point itself. Rather, it just has to understand how to transform that data point. And that means you can use very small models to do this, and they can teach models that are much, much, much larger than them, and you still get huge performance gains because the synthetic data model is just transforming the data. It's not actually creating it. The information is coming from the data point itself. Well, if you want to do this, there are two things that you have to get right. First off, how do you identify which data you want to augment with this rephrasing? And second of all, how do you actually do that rephrasing? itself. And there's a lot of nuance. This is an area where we have done literally hundreds of thousands of experiments to understand the best ways to do this. And what's cool about what we built here, and I'm really proud of, is we built a system that can now be applied to companies' proprietary data. So rather than it just being a synthetic data set, you can now, as a company, feed in your own data and have that be augmented and rephrased at scale in a really effective way. And we can do that for pretty low cost because we can use really small models to do this sort of rephrasing. So synthetic data is going to be, I think, a major part of all models going forward. If you look at any of the Chinese models, they actually all use rephrasing pretty aggressively, I think in some way inspired by some of the work that we've done. So this is definitely going to be a big part of the solution going forward, but it's also something that requires a ton of nuance, like most things in deep learning, and it can just as easily hurt your models as it can help your models if you don't do it right. So one of our goals is to make it so that everybody can do this easily and effectively, and we can help them do that.
Thank you so much. Okay, so now we're going to shift gears into the future, all right? 3 to 5 years from now, or even 30 years from now, what do you guys think is coming? What keeps you kind of? I still think we're in early days. I'd love to hear some of your thoughts about the future. Marcy?
Okay. Robotics, and it's kind of nice to be here at Google because they were always focused on this from the very early days, and I think
She took Google IPO.
yeah, that was a lot of fun. So you had asked, like, what am I super excited about? Because I think robotics kind of exemplifies a lot of secular trends, the marriage of hardware and software, and how do you think about a software-defined marrying of the physical world with the digital world. I think robotics has a lot of complex data issues, and one company that we recently invested in is Applied Intuition, and what's interesting about them is their mission is to add intelligence to anything that moves. And they started off in automotive, really working on autonomous software systems. But like similar to a lot of the things that we talked about, they started off in simulation, tooling, synthetic data, actually generation, and now moving up the stack, creating a vehicle OS. And then more recently, they launched their full self-driving autonomous software stack. And what's exciting is, even though they started off in cars, like when you think about anything that moves, that means drones, it means robotics, it means airplanes, it means anything. And very excited that there will be an intelligence layer added to anything that moves. And so when you actually look at their customer base today, it has moved from autos to defense, to construction, to mining, to agriculture. And I think this is a really exciting shift in movement and a huge area of growth.
Love Applied Intuition. Okay, now, Ari, I know part of the reason why you started your company was to create a generalizable kind of data layer for all of us. Please share some of your vision for the future.
Yeah, happy to. So when I think of what's necessary to build a successful startup, I think one thing is you have to have a core competency that really differentiates you from everyone else in the market. So what is that core competency for Datology? Well, we want to be the best in the world, and I think we already are, at valuing data with respect to a given downstream use case. So what that means is you can come and tell me, hey, I want a model that can do X, Y, Z, and I can tell you these are the data that will build a model that does that. That's fundamentally our core competency. That's what the majority of our team is always working on. How do we do that, and then how do we apply that at scale to petabytes of data efficiently and in an on-prem environment and all that sort of jazz. But that's our core competency. And if you think about curation, it's in many ways the most direct and obvious application of that core competency, right? How do you value data? But I think there's so many things that we can do beyond this. We're entering a new era where the primary consumer of all data is going to be a model. It's no longer going to be a data scientist with a Jupyter notebook, which I think is what it was in the early 2010s. And if you look at the big companies now, they were very much built on that layer. We're going to move in this totally different direction where almost all data is going to be consumed by models. And that's going to open up a whole bunch of new problems that we believe this same core competency will enable us to provide expertise on. So for example, we're going to move towards a world where all models are constantly constantly being fine-tuned on incoming data. This is already what happens at Google and Meta and at big tech companies for all of the ranking models. If you don't do this, the models are much worse. We're going to move towards a world where all of this is happening, and that's going to provide attack surfaces. That's going to make opportunities for people to poison models with bad data and things like that. We'll be in a great position to defend against that. We know that there's going to be lots of regulations that are coming around the world around data transparency, and those are going to be very hard to deal with. So there's going to be all sorts of just hairier and hairier problems around what data you show to models and how do you show it and how do you stay compliant doing so. And we want to be in a position to make those problems easy for everybody. So that's what we're going to be razor focused on for the next couple of years.
Amazing. Thank you so much.